thermal conductivity is K, F. On top of this is the moving layer of fluid, right, sitting in the boundary layer. So there is moving fluid. I perform a control volume analysis by drawing the following control volume. Because the first layer is static, what is the mode of heat transfer? The mode of heat transfer is conduction. Because these other layers are moving, the mode of heat transfer out of the static layer onto the moving layer is convection. So I'm going to have Q, and if I take this out, Q conduction to the fluid is equal to Q convection. This is at some local location along the length of the plate. And so if I do the energy balance, this is at y is equal to 0. This is at the surface of the plate. Q convection is equal to Q conduction, so H times Ts minus T infinity is minus Kf dt by dy at y is equal to 0. Does this make sense to everybody? This is basic energy balance at some local location along the length of the plate. First layer of the fluid is stuck, the other layers are moving. So I have conductive heat transfer to the static first layer, onto convection, onto the moving layer. You see this creature here will somehow be related to this guy here. And once we do that, we have H. You see that the Prandtl number is present. So by relating this to this particular person here, we will also have the Reynolds number come into the mixture, and eventually everything will be combined into the Nusselt number. That's the very last step. We'll do that on Monday. I'm going to start off from here, complete it in 5 minutes or so, and then it's all problem solving time. Thank you.